You're welcome to another interesting class today. We have a very simple problem on the board. This is a physics problem from JAMB past question. This is actually 1999 JAMB past question. And I'm going to use this question to teach us everything we need to know about the vibration of a string. So we have the lowest note emitted by a stressed string has a frequency of 40 Hz. How many overtones are there between 40 Hz and 180 Hz? Now, for us to solve this problem, like I said, I'm going to use this thing to summarize vibration on a string. So, let us consider a string that is fixed. Both ends are fixed. We have a string that both ends are fixed. Now, if I pluck this string on the center, a wave is produced. And this wave produced travels this way, gets to this place, then it is reflected back, and it comes this way back. This produces what? A stationary wave. A stationary wave or standing wave. A standing wave occurs when there is a superposition between a wave, an incident wave, and its reflected wave. That is, when two waves of the same frequency and amplitude traveling in opposite directions superpose, a stationary wave is formed. So we have the incident wave that gets to this place, then it is reflected back by this barrier and it returns back in opposite parts. Then we form what? A stationary wave. Now there are some important points we need to identify, or important parts of this wave we need to identify. We have a point of minimum vibration, which is referred to as a node. Is a point on a stationary wave where there is what? Minimum vibration of the particles of the wave. Then we have a point on the stationary wave where there is maximum vibration. Maximum vibration or maximum displacement. A point where there is maximum vibration or maximum vibration of the particles of the wave. We call it antinode. A. So here is another node. Here is an antinode. Here is another node. Now you can say that from here down to here is a cycle, one complete cycle. That means that distance there represents one wavelength. So each of this loop is a half of one cycle, or is half of a cycle, each of this loop. And with that now we can see that from node to node, the distance from node to another node is equal to half of the wavelength. Also, the distance from an antinode to another antinode, that is also half of the wavelength. You're getting it, right? Good. Now, you can also see that the distance from a node to an antinode will be equal to 1/4 of the wavelength. So from here to here is half of half, because this loop is half, which is what we identify here. Then from here to here is like dividing this into two, which is half of half again, which is lambda over 4. Are you following? All right. Now let's look at the different modes of vibration of this string. The different mode of vibration of this string. Let's look at this. So we have okay, let's look at a different mode of under mode of we have what we call fundamental mode of vibration. The fundamental mode of the vibration of a string. Now, when a string vibrates under fundamental mode, there is only one loop generated. There is just a single loop. And here to here represents the length of the string. From here to here represents the length of the string. That is just, so we have just a loop which is half of wavelength. So here we can see that the length of that string is equal to half of the wavelength. So if I make the wavelength the subject here, we can see that lambda, the wavelength, is equal to what? 2L. Are we following? So we now see that, recall that the velocity of a wave is equal to the product of the frequency and the wavelength. So by using this formula, we can see that F is equal to lambda, velocity over lambda. Now, under fundamental mode of vibration, this string vibrates with its lowest frequency, which is referred to as what? Fundamental frequency. Fundamental frequency is the lowest frequency, or the lowest frequency of a vibrating particle, or the lowest frequency of vibration of a particle is its fundamental frequency. So under this fundamental node, the frequency of vibration is what? Fundamental frequency, and that frequency is written as what? FO. F substitute, that is fundamental frequency, and that is equals to V over lambda. But here our lambda is 2L, so that gives us FO to be equals to what? V over 2L. Now this is the fundamental frequency of a vibrating string. Fundamental frequency of the vibrating string is this. I follow you. So this is the lowest frequency of a vibration. So velocity multiplied by, over 2 times the length of the string. Now, when resonance occur, now what is resonance? Resonance is a phenomenon where an object, where a body is made to vibrate with a frequency equal to its natural frequency as a result of the impulse received from another body vibrating with the same frequency. The phenomenon where a body is made to vibrate with its own natural frequency as a result of the impulse received from other body vibrating with the same frequency. Now, when the first resonance occur, so under first resonance, this is actually the first resonance. Now, let's use the word overtone. Let's talk about overtone. Now, overtone is more of like, is an integral multiple of the fundamental mode of vibration. An integral multiple of the fundamental mode of what? Vibration. An integral multiple of the fundamental mode of what? Vibration. That is what we call overtone. So now for the first overtone, the particle vibrates this way. There is just an additional loop. Just one additional loop added. From here to here represent the wavelength of the wave of the string. Now we can see, and also this place is also equal to the length of the string. We can see that the length of the string is actually equal to what? To wavelength. So from f equal to v over lambda, we can simply say this is equals to what? V over L. Now let's compare this and this. If you look at this and this, you see that the difference between this and this is just 1 over 2. That if I multiply this FO by 2, you can see that this particular frequency, this frequency of vibration here is actually the frequency of the first overtone. And this frequency of the first overtone is actually the kind of 2 times the fundamental frequency. You can see that if I multiply this V over 2L, if I multiply it by 2, this cancels this and it gives me V over L, which is equal to this. So we can simply say that this frequency of the first overtone is equal to 2 times the fundamental frequency. So this is for the first overtone. Let's look at second overtone. Second overtone. Okay, now at second overtone, we're going to have extra loop added. We have the fifth end, just extra 1 loop. We can see that from here to here represents the length of the rope, and we can also see that from here to here is 1 wavelength, and from here to here is half. So this is 1.5 wavelength, which is 3 over 2 lambda. So we can see that L is equals to 3 over 2 lambda. Please don't get confused. This from here to here is 1 cycle, which represents 1 wavelength, and this one is half of a cycle. So the total wavelength here is actually the 1 wavelength plus half, and that is this. I hope you are with me. All right. So that means L, if you make lambda the subject, we have that 2L is equals to 3 lambda. So that means lambda is 2L all over 3. So the frequency of this, which is what we call second overtone, F2, second overtone, will be equal to, remember, V over lambda. And this is equal to, this will be equal to this is V over, our lambda is 2L over 3. And that will give us a 3V over 2L. Now, when we look at this, we can see clearly that this value is actually, remember, FO. Let's come back here. FO is equals to V over 2L. So you see, when I remove this 3, I have V over 2L. That means this F2, the frequency of the second overtone, is actually equal to 3 times the fundamental frequency. Are we following? All right. So let's get one more. Third overtone. In the third overtone, please, in each overtone, simply add extra one more loop. In each overtone, you add one more loop. So in the third overtone, let's still do the same thing. We have, excuse me, let's make it look better. Just one more loop. Just one more loop. So you can see from here to here represents the length of the rope L, and this length is actually equal to what? 2 wavelengths, because from here to here is one cycle, one wavelength. From here to here is one wavelength. From here to here is another one wavelength. That is 2 wavelengths. So we have that L is equals to what? 2 lambda. So wavelength is equals to L over 2. Following, right? Okay. So the frequency of this third overtone, which is F3, will be equal to V over lambda, and lambda is L over 2. We can now put it to be equal to V over L over 2, and that gives us what? 2V over what? L. So we can see that, recall, let's come back again, look at the fundamental frequency. If I multiply this by 4, 2 takes up this, 2 takes up this, and that gives us 2V over L, which is what we have here. Therefore, the frequency of the third overtone is equals to 4 times the fundamental frequency. Are you noticing something very interesting here? You see that the frequency of the overtones is simply integral multiple of the fundamental frequency. The fundamental frequency is just FO. First overtone 2FO, third overtone 3FO, fourth overtone third overtone is 4FO, and so on. That is how it is going. So you see that if you are to do the next one, if you are to get the frequency of the fourth overtone, you end up having what? 5FO. Please, you can try it out. You see, it will give you 5FO. If you do the next one, 6FO. All you need to do is just for each one, add one more loop. For each one, add extra loop, and nothing more. So that gives us the overtones for a vibrating string. After you have gotten your fundamental frequency, the first overtone, we have F1, which is 2FO. Second overtone, F2, is equals to 3FO. Fourth overtone, F4, sorry, third overtone, F3, is 4FO, and so on. And that is how the thing goes. So we can see that the frequencies are in the form FO, 2FO, 3FO, 4FO, 5FO, and so on. Are we good? All right. So please, this can also be referred as what? Harmonics. Harmonics are also in the integral multiple of the fundamental frequency. But the difference between harmonics and overtone is harmonic starts from the lowest frequency. So if I'm to identify the first harmonic, this is first harmonic. This is first harmonic, second harmonic, third harmonic, fourth harmonic, fifth harmonic, and so on. But in terms of overtone, the overtone starts from the first multiple. This one, the first overtone. This is the first overtone, second overtone, third overtone, and so forth. So the overtones excludes the lowest frequency, but harmonic starts with the lowest frequency. Please take note. So you can also consider these things as harmonics. If I remove this, these represent overtones. So now let's go back to this question and get our answer. Let's get our answer here. So we are going to have something like this. That if FO solution to this question, they say the lowest note emitted by a string, the lowest note will have its lowest frequency, which is fundamental frequency. So the fundamental frequency of the string is equals to what? 40 Hz. So we want to know how many overtones we're going to have. The first overtone is equals to 2FO, and that is equals to 2 times 40, and that is 80 Hz. Now second overtone is equals to 3FO, and that is 3 times 40, and that gives you 120 Hz. The third overtone is going to be 4F0, which is 4 times 40, and that is 160 Hz. Then fourth overtone is equals to 5FO, which is equals to 5 times 40. 5 times 40, and that is 200 Hz. Now let's pick our answer. They said between 40 and 180. So these are the values that occur between 40 and 180. So this is already 200 above 180. So how many overtones? We have 3 overtones. 3 overtones. 3 overtones. 3 overtones. Sorry, please. This option, this is option 3. This is option is actually 3. I cleaned it when I was here. I click that number. So the correct answer there is what? Option D. I trust you enjoyed the video. Please, if you did, kindly click at the like button and do ensure you share with your friend. If there is any topic you would want me to make a video on, just put it down there on the comment section. See you in my next